Good morning, everyone. My name is Adriel Aseniero, and it's a pity that I'm not able to join all of you over there in Italy due to the current state of the world. However, as a virtual attendee, I'm still very excited to present my talk about Activity River, visualizing planned and logged personal activities for reflection. First, I would like to acknowledge my awesome co-authors on this project, Dr. Charles Perin, who's with the University of Victoria, Dr. Wesley Willett with the University of Calgary, Dr. Anthony Tang, who's with the University of Toronto, and Dr. Sheelagh Carpendale, who's with Simon Fraser University in Canada. So here's the structure of my talk. First, I would like to talk about some background of what the project is about. This project is mainly about supporting self-reflection, which is the process by which individuals learn about themselves to gain insights for self-improvement. Now, there is a lot of emerging research about this topic in human-computer interaction, such as personal informatics, and in information visualization, such as personal visualizations and personal visual analytics. And this stems from the emergence of new technologies concerning personal data, such as fitness trackers and the like. The idea is that we can use these data to learn about ourselves, like our habits, so that we can make good behavioral changes. So these visualizations are hence personal visualizations, which are interactive visual data representations for use in a personal context. So fitness trackers, for example, automatically tracks people's physical activities. It also allows them to set personal goals, which they can attempt to reach in order to become less sedentary and healthier. These tools typically use basic visualizations like bar charts and pie charts, which we assume that many people are familiar with. However, these usually only show status and historical data, but leaves other context hidden. For example, if a person looks back at their data and sees a time when they didn't have a lot of physical movement, it is up to them to remember what they were doing at the time. Now, there are methods that some people already do, such as keeping diaries, journals, and calendars, which can offer a wealth of contextual data about how events unfolded in an individual's life. Also, rather than limiting the definition of activities to physical activities, these tools enable people to be more specific about the activities that they log. So this project that I'm presenting is an exploration on how visualization tools could support individuals as they plan and log their daily activities, and how visual exploration can enable them to reflect and learn from their data. In order to build our visualization tool, we looked at research considering reflection, goal setting, personal visualizations, and other life logging methods. From these related literature, we distilled 5 design challenges informing our design goals for personal visualizations that support planning and logging activities and self-reflection. The first comes from the design challenge that self-reflection tools should present historical data with an appropriate level of context. Second, self-reflection tools should facilitate comparison and show discrepancies between goals and achievements. Third, self-reflection tools should provide delightful, pleasing, and engaging visualizations. Fourth, self-reflection tools should provide ways for individuals to author their life logs. And lastly, the fifth, is that self-reflection tools should provide agency to individuals through flexible means of managing their goals. Using these design goals, we implemented which is a visualization tool for planning and logging self-defined activities and visualizes data through a modified stream graph representation. Up here on the top right-hand corner are the self-defined activities an individual wishes to track. The middle shows the visualization of planned and logged activities for a single day. And the bottom part shows the week's worth of log data as small multiples of the visualization. the current or selected day is highlighted. When an individual makes an account with Activity River, they can first define the activities they wish to log. They can be as loose or specific as they want, and they are free to assign the colors to the activities as well. The activities are then visualized by the colored bands or waves in the timeline stream. Again, this timeline stream is a modified stream graph, and to read the visualization, we first look at the horizontal axis, which contains discrete marks called time slices. These time slices contain the 24 hours from midnight of a given day to the next. You may think of these as the categorical marks of a stream graph. In the middle of the vertical axis, we have the baseline of 0, which separates the two parts of the timeline stream. Above the baseline is a stream that shows the logged activities or those that actually happened. And below the baseline is the reverse stream that shows the planned activities or the goals of the individual. The length of an activity wave in each time slice shows the amount of minutes the individual spent or planned to spend on an activity. When two or more activities are stacked on top of each other, that means the activities overlapped or happened at the same time. For example, here, at 2 p.m., the individual spent 30 minutes on the blue activity, as well as 60 minutes on the green activity, and they also overlapped. To help with readability, an individual can click on an activity wave to pull it down to the baseline. More than enabling people to delve in exact reading and analysis of how much time they spent on an activity, Activity River is about giving individuals an impression of how their plans compared with their logged activities. The more symmetric the timeline stream looks, the closer they are to adhering to their plans. Also, the dominant colors can give individuals an idea of which activities are consuming most of their time. Which leads us to how to plan activity. To plan activities, individuals can access the diary logging page, which allows them to select activities and plan when they wish to do them. For example, here, the individual selects rest and sleep and puts it at 1 a.m. until 9 a.m. Once finished, the planned activities will then show up on the timeline stream. For flexibility, we implemented two ways of logging activity. First is on-the-go logging. If you noticed earlier, there's an animated border on one of the activities on the legend. This is because individuals can use the legend to toggle activities on or off, like so. Ongoing activities are marked with the animated dashed border, and the tool will continue to record this activity until the individual toggles it off. So you can toggle activities on or off by simply clicking on them. Multiple activities can be selected at the same time as well to account for activities that can happen at the same time. The second way of logging activities is similar to planning through the diary logging interface. When accessing a day that has already passed, the diary becomes for planning. As seen here, instead of saying planned activities, it now says actual activities. Individuals can then select the activities and set the time when they have happened. They can also use this to correct any mistakes they may have done with the on-the-go logging, such as when they forgot to toggle an activity on or off at the correct time. They can also add notes about the activity which they could use to add more context about what had happened. While we mostly designed Activity River's prototype as a desktop application, we implemented it as a web application using HTML5 and JavaScript, which makes it accessible on mobile devices. To explore the strengths and limitations of our design approach, we conducted a qualitative study examining how students who use calendars or diaries used Activity River to plan, log, and reflect on daily activities. We focused on how they used the tool and how they behaved when adjusting and reflecting upon their plans. At the beginning of the study, we gave them a pre-study questionnaire asking them of their demographics and methods of life logging. We recruited 10 university students, 6 female and 4 male, who already life log or use diaries, calendars, and or other apps to plan and record their daily activities. So all of them used calendars and to-do lists to a varying degree. 7 had used calendars for more than a year, while the rest had used them for about a year. Only 3 of the participants were actively keeping diaries and journals at the time of the study, while 2 had kept diaries in the past. Most use such tools to organize their schedules and daily tasks. Because personal activity data can be quite sensitive, we designed a role-playing method to help individuals maintain privacy during the study. This also allowed us to significantly shorten the length of the study and scope it into a lab experiment rather than in the wild study, which require more resources and preparation. In this method, we allowed the participants to choose a character from 3 student personas: the studious senior student, the active student athlete, and the carefree freshman or first-year student. We provided a character information sheet for each character which contained their motivations, a typical schedule, and activities. And using these character sheet, we let the participants role-play as a character, assign colors to activities, and then plan their goals. We then go through a scenario of a typical day from when the character wakes up until they sleep. And these scenarios are made of scenes, usually per hour of the day, where we narrated what events are happening and let the participants enact what they would do as the character. We also allowed them to record and log any of the activities that they are doing. To simulate the passage of time, we implemented a way to fast-track Activity River's recording into chunks of 5 minutes or 1 hour. And at certain points in time, such as when they woke up, at lunch, and near the end of the day, we let the participants draw a card from 8 life cards. So life cards simulated unexpected events that may happen in real life which would necessitate a change in plan. Each card varied on how long they interrupted the participant's schedule, ranging from small disruptions, such as a 1-hour delay, to big ones like the cancellation of a whole event. After the scenario, we interviewed each participant and asked them how they related to their chosen character and how knowing the character's goals and motivation affected the way they role-played and planned for the day's event. We video recorded each session and collected participants' comments during the interviews. We then used open coding to identify themes and trends in the data. We also recorded their usage of Activity River, which allowed us to re-visualize their plans and logs during the study. For more information on our results and discussions, I invite you to read our paper. I would like to highlight some visual planning patterns that our participants used when they needed to modify their plans using Activity River. The first pattern is forward shift. So we observed 7 participants shifting activities to a later point in time. For example, when participant 7 had to extend his sports activity, he pushed his studying to an hour later. This could also occur when a participant missed an activity they wanted to do, in which case they did it at a later time. The second pattern is backward shift. The 7 participants shifted activities to an earlier time than they had originally planned. This occurred when participants realized that they had free time earlier in the day. For example, participant 6 got sick due to a lifeguard, so instead of having fun outside with friends, they decided to study and sleep earlier than they had planned. Third is replacement. So 9 participants replaced at least one planned activity with a different activity. For example, when participant 5 decided to not go to work like they originally planned, they instead sleep and study instead. Next is addition. 6 participants performed an activity which they did not originally plan to do so. And this usually happened during their free time. For example, participant 4 decided to take a nap during a break in their schedule. The fifth pattern is lengthening. 7 participants extended the duration of an activity beyond what they had originally planned. These extensions were often compensations for missing part of an earlier instance of the activity. 6 is shortening. So 4 participants cut the scheduled ongoing activity short. For example, participant 9 planned to work for 4 hours, but instead shortened it by 1 hour to catch up on a plan which they didn't do earlier. These visual planning patterns suggest that the visualization enabled dynamic and continuous reflection, which helped individuals make informed, quick decisions to adapt to unforeseeable circumstances and reach their goals. This also led us to the idea of supporting other forms of planning. For example, there are activities in which the amount of time spent on it mattered more than when it was scheduled. These can be thought of as bankable activities, in which individuals first set an amount of time as their goal and then work towards that amount whenever they have time to do so. For example, participant 4 didn't really care when they needed to study as long as they were able to study for an amount of time. So we consider bankable activities as a class of activity where identifying start times may be difficult or altogether inappropriate. And this is currently not so well supported in Activity River, which we would like to explore more in future work. Our participants also rated the aesthetics of Activity River highly and were interested in personally using it for more than a week in order to see how their data would look. So this suggests that the aesthetics of the timeline stream, with its flowing symmetry and vibrant colors, sparked curiosity in our participants. And while not necessarily an emotional investment, curiosity is a motivator which can initiate further exploration of the tool. So for example, some of our participants said that they really like the symmetry of the visualization if their plans matches their logged activities. This also brings us to the importance of authorship, where self-definition of activities can allow the people to tailor the visualization to fit their needs, and as well as personalize it to put some more personal meanings into their data. For future work, the majority of our participants requested to integrate Activity River with tools that they already use. For instance, participant 4 said that she would like to connect it to her digital calendar because she wanted to see the timeline stream of her actual activities, but still wanted to plan using the calendar's interface. We're also looking into getting data from existing apps that let people track their self-defined activities like Toggle. Another thing is to exploit the scalability of stream graphs and implement transitions between day view, week view, month view, maybe even a year's view perhaps. We also acknowledge that while we use Activity River to visualize activities, individuals could also use it to visualize other data such as whether they are adhering to their budgets and medication intake. Also from our study, we observed how our participants used it to communicate their ideas, which made us think about how it could be a tool for collaborative planning such as between coaches and athletes. To conclude this talk, I would like to reiterate our contributions. First, the design goals for designing personal visualizations for self-reflection. Next is Activity River, the application itself as a proof of concept tool for planning, logging, and reflecting on personal activities, and a role-playing study of Activity River and its results, in which we found that participants were able to use it to progress towards their goal. In particular, our timeline stream visualizations have enabled dynamic and continuous reflection to help individuals make informed and quick decisions to reach their goals. And that is the end of my talk. Thank you very much for listening, and I am now ready to answer your questions. Thank you.